for summary, this experiment is to demonstrate the typical flow measurement device for incompressible fluid, which are rotameter, ventimeter, and orifice plate, and to compare the difference in flow rate incurred by each of these devices. Flow meter apparatus was used in this experimental, and all raw data obtained were recorded in order to calculate the flow rate using Bernoulli equation. All the flow rate were standardized to liter per minute so that it is easy to do a comparison. The difference in flow rate for each device came from the friction loss from inner wall and design of streamline of device. Besides, the difference also came from the error of the device and the human error like parallax error. However, this error can be reduced in order to give the most right result. Hence, the objective of this experiment was successfully obtained.
There are two aims for this experiment. The first one is to demonstrate typical flow measurement devices for incompressible fluid. The devices are venturimeter, orifice plate, and rotameter. The second aim is to compare the difference in flow rate incurred each of these devices. So, here is the introduction of the experiment. Flow measurement strategies other than positive relocation flow meters depend on powers created by the flowing stream as it beats a known tightening. So in a roundabout way, figure stream. Stream might be estimated by estimating the speed of liquid over a known zone. Liquid measurement of a large number of the factors and properties, for example, thickness, consistency, weight, speed, stream rate, and so forth, is one of the issues most regularly experienced by architects. It is along these lines basic for designers to be very much furnished with information of the essential and existing strategies for estimating different liquid properties and wonders. This mechanical assembly is exceptionally intended to acquire the stream rate estimation by using three essential sort of stream measurement strategies, which are glide type, flow meter, venturimeter, and orifice meter.
Firstly, we talk about the rotameter. So the rotameter is a stream meter in which a turning free buoy in the showing component. Fundamentally, a rotameter comprises of a straightforward decrease vertical cylinder through which liquid stream upward. So inside the cylinder is put an unseverely suspended skin we call of siphon wave shape. And at the point when there is no stream, the buoy lays on a stop at the base end. As stream start, the buoys descend until upward, and then its lightness powers on it are adjusted by its weights. The buoys rises just a short separation if the rate of stream is little, and the other way around. And the purpose of harmony can be noted as a component of stream rate. With a well-adjusted check glass tube, the dimension of the buoy turns into immediate proportion of stream rate. So next is the venturimeter. Okay, the venturimeter comprises of a venturi tube and a reasonable differential weight measure. The venturi tube has a meeting segment, a throat, and a wandering beam as appear in the figure underneath. The capacity of the uniting segment is to expand the light of the liquid and lower its static weight. Weight distinction among channel and throat is in manner created where the weight contrast is related with the rate of release. And wandering cone serve to change the territory of the stream back to the passage region and convert speed heat into a weight lift. So the basic formula for this venturimeter is we use the delta H equal to H3 minus H4. So next we're going to orifice meter. The orifice meter is for use as a metering device in a pipeline comprises of a concentric square edged roundabout opening in a merger plate, which is hinged between the ribs of the pipe. So, in this orifice meter, the pressure connection for joining separate weight checks are made at gaps in the pipe divider on both sides of the orifice plate. The downstream pressure tab is set at the base weight. So, in the position which is thought to be at the vena contract. So, the focal point of the delta weight tab is situated between 1/2 and 2 pipe breadth from the upstream of the opening plate. Ordinarily, a separation of 1 pipe distance across is utilized. So, for this orifice plate, we usually use formula as delta P equal to delta H rho G. So that's all. So the experimental result is as shown as this.
In order to conduct this experiment, all the connections were checked to make sure they were connected. Aside from the inlet valve, all valves at pipe area and the 6 cylinders manometer were opened. The inlet valve was opened gradually to give the water a chance to stream for one moment and the siphon exchange on. All air was quarantined has been out from the pipework. The pump was turned off. At that point, the outlet valve, vent valve and drain valve were shut. Drain valve opened and the height of the manometer tubes were acclimated to 150 mm by vent valve 3 to 4 round opened. Inlet valve gradually opened and the pump exchange on. Until get the difference in levels between every manometer, the height of the water in the manometer tubes were balanced with the assistance of inlet valve. The rotameter reading were set at 200 liters per hour. The time taken for the water to fill into 20 liters were recorded in table 1. Same goes to the manometer reading. These steps were repeated by setting the rotameter reading at 300 liters per hour, 400 liters per hour, 500 liters per hour, and lastly 600 liters per hour.
Okay, going to analysis and discussion regarding these experiments. Based on the result obtained, the flow rate of the venturimeter and orifice meter was increased as the flow rate of the rotameter increased. So, the orifice meter has more precise flow rate compared to the venturimeter. This was shown by the different were calculated in the table. The difference in flow rates was also be given by the parallax error, which was eyes were not perpendicular to the scale of manometer while reading is taken. Besides, the scale was not precisely scaled and it was hard to take the reading when the heat of water level is in manometer was in between 2 points. For example, the water level was in between 150 millimeter to 155 millimeter. The actual reading was estimated without knowing the actual value. So going for point for discussion in the experiment, regarding this experiment, we need to determine the flow rate. of the venturimeter and orifice plate. So we represented these two type of measuring flow measuring device as Q. So to find the flow rate, we need to use this formula. So the formula for this flow rate is K times square of delta pressure.
Now, let's move on to the point for discussion. There are four limitations of Bernoulli's theorem. First, the equation of Bernoulli ideally applies to fluids with zero viscosity or non-viscous fluids. Second, ideally it applies to fluids with zero velocity and non-viscous fluid, but not to the viscous fluid. Third, Bernoulli equation applies only to streamline fluid flow, which is not valid for non-steady or turbulent flow. Last, the fluids must be incompressible, as the fluid's elastic energy is also not taken into consideration, which is not the case since most common liquids, such as water, are almost incompressible. Second point is, the primary considerations when selecting a flow meter to measure a fluid's flow rate are device size, fluid composition, required level of accuracy, head loss, installation and operating environment. The last point is, by flowing the fluid through the closed channel of the variable cross-section, the flow rate is measured with obstruction type flow meters. This channel has varying cross-sections and we consider two cross-sections of the channel, which is 1 and 2. Let the pressure, velocity, cross-sectional area and height above the datum be expressed as P1, V1, A1 and Z1 for section 1 and the corresponding values for section 2 be P2, V2, A2 and Z2. We also assume that fluid flow is incompressible and flows horizontally. The orifice meter are cheap and easy to install in the pipeline because it is just a flat plate and a thin orifice plate. Compared to orifice meters, the venturi meters are more expensive as it must be carefully proportionate and manufactured. Second, compared to venturi meters, the orifice meters have greater head loss, high permanent head loss, hence high energy consumption to overcome head loss, and pumping the liquid requires more pressure. Lower head loss in venturi meters reduce capital expenditure on pumping and save energy costs for pumping. Last, the accuracy in orifice meters is poor at low flow rates. High accuracy depends on a good shaped orifice meter with a sharp edge to the upstream side. Venturi meters are very accurate over wide flow range and the gradual contraction and expansion reduce the drag and allows a low pressure loss.
In conclusion, flow rate is amount of fluid traveling through a pipe which pass per unit time, normally represented as SQ. The SI unit is meter cube per second. In this analysis, flow rate was estimated by utilizing orifice meter, venturimeter, and the rotometer. From the information acquired for the orifice meter, high pressure drop is unrecovered. This is because of the flow rate is expanded at the opening at the orifice plate and not much energy loss, but rather as it goes through and begin to backing off. A great part of the evidence vitality is lost. At that point, considering rotometer, the vitality means floating over parameter higher than the venturi and orifice flow meter. This high vitality means floating is because of the expensive drop in the weight because of gratting. For the venturi meter, the esteem were nearer to the real flow rate. This is because lower pressure drop that come from this streamline shape nearly take out limit layer detachment and accordingly structural drag except immaterial. It as joining and wandering part. Although there might some weight misfortune in commanding some portion of the ventrimeter, yet legitimately plant ventrimeter some level of weight misfortune achieved back and splitting some portion of meter. This meter is useful for height, weight, and fatality rectification. To be close, adventure was increasingly exact contrast with orifice and rotameter. From this experiment, the objective has been achieved.